Okay, so in this video we discuss tutorial question. Okay, we're gonna do question 6b first. I think 6a is pretty much similar to 6b. You can try it yourself. Okay, for 6b, they want to convert 2600 rpm to SI unit. So rpm is actually unit for omega, angular velocity. So omega is equals to 2600 rpm, which is revolution per minute. Okay, so to convert to SI unit, which is radian per second, basically I'm gonna do cross multiply. Okay, I think I showed it before. I just want to show it like one last time lah. So omega here 2600 revolution per minute. Okay, so basically you want to cancel out revolution and you want it in terms of radian. So you have to put your revolution in opposite side lah, which is down here, so that you can see we cancel out. Okay, you want it to be in radian, so radian, and then you want to change minute to second, so you want to cancel out minute, so it has to be in opposite position. Minutes down there, so you have to put it up here, and then you want to have in second, so minutes cancel out, and then you left with radian and second. Okay, now you have to ask yourself, one revolution, which is one complete cycle, is equivalent to 2 pi radian, and 1 minute is equivalent to 60 seconds. Okay, so basically you just have to press your calculator. 2600 times 2 pi divided by 60 seconds. Okay, so omega here you should get 272.27. SI unit is radian per second. Okay, next question is question number 7. It says that a bucket of mass 2 kg rotated at a constant speed in a vertical circle of radius 8 meter. The bucket makes one revolution in 4.2 seconds. For the bucket position at maximum height, calculate the magnitude of angular speed, linear speed, and centripetal acceleration. So whenever you get this kind of question, you have to take out the information given and you have to write it down in terms of appropriate symbol. Like this one, mass is 2 kg. Okay, if it is not in SI unit, you have to change to SI unit lah. M is equals to 2 kg. M represents mass. Radius 8 meter, that one is your R. Again, double check the unit, and then the bucket makes one revolution in 4.2 seconds. So when the question state one revolution, immediately student tend to write or tend to assume that this one is actually theta. It's not theta because this is given value, which is 4.2 seconds. If you are not sure, you can always check the unit here. Okay, second represent time, so obviously this one in terms of time, so obviously it's a T. Now the next question, whether it's a small t or capital T. Okay, so the bucket makes one revolution in 4.2 seconds. It means that in 4.2 seconds the bucket makes one complete cycle. So that one is actually your capital T period. Okay, so you have to write in correct symbol. If you write in terms of small t, then most likely you cannot answer the remaining question. Okay, so the question want to find angular speed. Okay, write it down in terms of symbol, which is omega. Linear speed V. Centripetal acceleration is AC. Okay, then only you can solve. A, angular speed omega. Okay, so you are given period, so you have a few formulas for omega. If they give you like initial angular displacement, final angular displacement, maybe you can use delta theta over delta t, but they didn't give you those information. They just give you period. That one is enough. So actually the formula is delta theta over delta t. But if you are talking about one period, one complete cycle, remember the theta for one complete cycle is 2 pi. So this is the formula. Alternatively, you can if they give you in frequency, you can write 2 pi f lah. Now you just have to substitute the values of period, which is 4.2. You should get 1.496. Okay, if you round it off to 2 decimal point, you should write it in 1.50 radian per second. Okay, question B, they want to find linear speed. So V, the relation between V and omega is V equals to R omega. You do know the values for R, which is 8. Omega you calculated just now. So this one should be 12. Yes, it's 12 meter per second. Okay. Now for C, they want you to find centripetal acceleration. This one comes from the previous formula. AC equals to V squared over R. So you just left with 12 square divided by 8. So it will be 144 divided by 8. That one is 18. Okay, the unit for centripetal acceleration is basically just a unit for linear acceleration, which is meter per second square. Okay, so be careful because this one is omega, angular velocity, unit is radian per second, linear meter per second, linear meter per second square. Okay, so next question is question number 8. A deep sea fisherman hooks a big fish that swim away from the boat, pulling the fishing line from his fishing reel. The whole system initially at rest. The fishing line unwinds from the reel at the radius of 4.5 cm. The reel is given an angular acceleration of 110 for 2 seconds. What is the final angular velocity, speed of the fishing line? How many revolutions? How many meters? Okay, so those are the questions. So again, once you get the question, you have to take out the information, write it down with an appropriate symbol. So the first information, it says that it is initially at rest. So if you remember in topic 2, initially at rest means u equals to 0. But now we are talking about angular velocity. We represent this one in terms of omega. Initial angular velocity is omega naught. At rest means 0. Okay, and then it says that the radius is 4.5 centimeter. You can straight away change to meter. 0.045 meter. And then the real given angular acceleration. Okay, this one, if you're not sure what is the value, what is the symbol for angular acceleration, you can always double check with the unit. Okay, radian per second square is obviously alpha. So alpha is 110 radian per second square for 2 seconds. Okay, it doesn't state that one is for one complete cycle, so that one is basically just a small t. Okay, the first question, they want to find the final angular velocity. They want to find omega. They give you omega naught. Okay, what is the speed of the fishing line? Speed, so that one is linear speed, which is v. How many revolution does the reel make? Okay, how many cycle? So that one represent with actually theta. Okay, but remember SI unit for theta is radian, so the question actually want you to find in terms of revolution, so you have to convert afterwards. How many meters of fishing line come off from the reel at this time? That one is S. Okay, because it says meter. Meter is indicator, it is actually linear displacement. Okay, so you want to solve this one. So you are given omega naught, you are given alpha. Most likely you have to use those four in equation. So previously you have v equals to u plus at. Now you have omega equals to omega naught plus alpha t. S equals to ut plus half at square. Okay, this one, so basically this would be theta omega naught t plus half alpha t squared, and then we have omega squared equals to omega naught squared, v squared equals to u squared plus 2 alpha theta, and then lastly we have theta equals to half omega naught plus omega t. Okay, now you are given omega naught and alpha. Okay, you can choose any formula that has omega naught and alpha. So obviously, okay, you also have time, so most likely you want to use this formula. Okay, contains omega, omega naught, and alpha t. So omega is equals to 0 plus alpha t, which is 2. So 220 radian per second. What is the speed of the fishing line when it leaves the reel after 2 seconds has elapsed? Okay, so basically omega that we calculated just now is omega when t is equals to 2 seconds. Okay, so if you want to find v when t is equals to 2 seconds, you have to use r omega when omega is at t equals to 2 seconds. So basically v equals to 0.045 times omega, which is equals to 220. So this one I got v equals to 9.9. So the unit SI unit for velocity is meter per second. Question C, they want to find how many revolution does the reel make. That one is your theta. So again, refer back to the equations. Which one you want to use? I mean, in terms of theta, you can use the second one. I think I can use the third one as well, but I'm going to use the second one. I think I'm going to use a new page instead. Okay, theta is equals to omega naught t, s equals to ut plus half a t square, alpha t square. Okay, so theta is omega naught is 0, so the whole terms there become 0. Alpha is equals to 110. T square is 2 square. If I'm not mistaken, it would be 220, but I just double check. Yes, it's 220 radian. Okay, but the question want to find in terms of revolution, so obviously you have to convert lah. So theta 220 radian, you want to cancel out the radian, you put radian down here, you want to end up with revolution, so you put revolution up there. Radian cancel out, 1 revolution equals to 2 pi, so 220 divided by 2 pi should get 35.01. Okay, theta in revolution. And then the last part here, they want you to find how many meter of fishing line come off the reel at this time. So basically you want to find s equals to r theta. At this time means when t equals to 2, so you have to use when theta t equals to 2. Okay, that one you already calculate up here. Okay, but if you want to have s in SI unit, which is meter, you have to use theta in SI unit, which is 220 radian. R just now is 0.045 multiply with 220. So everything here is as SI unit, so final answer will be in SI unit as well. Okay, and then for question 9, it says that a rigid body rotates about fixed axis through a point in the body, uniform angular velocity of 600 rpm. The velocity then decreases at a constant retardation to 300 rpm in 6 seconds. The main angular acceleration, number of revolution, extra time needed for the body to come to a stop. Okay, so 600 rpm, and then you have 300 rpm. So you know, based on the unit itself, both of these are omega. Okay, so the difference is one is initial omega, another one is final omega. So initially it is at 600, so that one will be omega naught, and final will be in omega. Okay, and then the time given is 6 seconds for it to decrease from 600 to 300 rpm. So if you want to solve this one, the first question you want to find angular acceleration alpha, second question number of revolutions, again this one is actually theta, and extra time needed, so they want to find t extra for the body to stop. Okay, so if you want to solve, obviously you have to apply these four formulas. So I just copy it from here. Oops. Okay, but remember, if you want to use this formula, you have to convert to SI unit first. So RPM is not in SI unit, you have to convert. So it is actually revolution per minute, so you want to cancel out revolution and so on. So it will be so I just do it up here. So RPM is actually equals to revolution per minute. So you want to cancel revolution, put revolution down here. You want to have in radian, and you want to cancel out the minute to have in second. 1 minute 60 second, 1 revolution is 2 pi. Okay, so basically you multiply 600 with 2 pi, and then you divide by 60, you should get in terms of radian. Okay, again you can do the same method. Basically 300 multiplied with 2 pi divided by 60, you should get in radian per second. Okay, and then t is 6 seconds. Okay, the first question I want to find angular acceleration, so you can use one of these formula. You don't have theta, so you can cancel out theta. You just left with the first one. Okay, so A, you can use omega equals to omega naught plus alpha t. Okay, omega is 62.83, omega naught is 31.42, alpha you want to find, time is 6, so 62.83 minus 31.42 divided by 6. Okay, I think I put this one omega and omega naught incorrect. Okay, so it should be omega naught is 600 rpm, so that one would be 62.83, and this one should be 31.42. That makes sense. So actually the object decelerates. That's why they use the term decrease, constant retardation. 31.42 minus 62.83 divided by 6. I got alpha equals to negative 5.24. Okay, radian per second square, SI unit. Okay, so here the negative means it is actually in this case, if we assume, since we assume omega is positive, which means it is to the right, so I mean not to the right, it would be clockwise, so this one will be anti-clockwise. Okay, for next question yang B, the number of revolution the body has turned through in 6 seconds. So basically the question was to find theta. So again, you can use any of this formula. Maybe you can use the last one, right? Again, you can use the second one as well if you want to. Then you have enough information to use any of those formula. So the last formula is theta equals to half omega plus omega naught t. So it will be half final velocity. I mean, this one is plus, so it doesn't really matter, but we just want to substitute with correct values there. 31.42 plus 62.83 times 6 times half. Theta is 282.75 radian. Okay, double check whether the question want you to find in terms of revolution or radian. Yes, they want you to find in terms of revolution, so you have to convert. Radian you put down here, revolution up here. 1 revolution 2 pi radian. So theta in terms of revolution, 282.75 divided by 2 pi. So I got here is 45.00 revolution. Okay, and the last one, they want to find the SR time needed for the body to come to a stop if it continues to slow down at the same rate. So I just want to copy this formula. Okay, maybe I can do it in new page. Okay, now they want you to find extra time needed for it to completely stop. So assume that this is like a timeline. So initially in 6 seconds, so the object reduce omega from, in terms of radian, it would be 62.83, decrease to 31.42. Okay, the time taken is t equals to 6 seconds. The alpha taken is negative 5.24. Okay, now it says that if the object continues with the same deceleration, what will happen with the how long does it take for it to completely stop? So that one is 0 lah. It means that omega is 0. So this would be your final omega. This would be your initial, because they want to find those extra time. So basically they want to find this t. Okay, they want you to find total time, so maybe you can use omega naught as 62.83, but they want you to find that extra time needed for it to completely stop. Okay, again from this formula, we don't have theta, so we can choose the one without theta, which is the equation 1. Omega equals to omega naught plus alpha t. Omega is 0. Omega naught is 31.42 plus, okay, it has a negative, so just put negative there, t. Okay, so you bring negative 31 to the other, 31.42 to the other side, it becomes positive 31.42 divided by 5.24. So time taken is 5.996 or 6.00 second.